so sorry, I had someone at my door, so that was a quick one. But for the rest of those definitions, we're not going to talk about a complex plane or the absolute value, so you can just cross those out because we don't do those in Algebra 2. So you can just X those last two out. And now we're going to jump to the adding and subtracting, which is so much easier. Okay, the nice thing about adding and subtracting is that it's just like if we're dealing with variables. Okay, so all we do is, we've got, these are two complex numbers, and all you do is you add the real parts and you add the imaginary parts. So it's just like terms, okay? So remember, a subtraction, just like we did in polynomials, a subtraction here means add the opposites. So I'm just going to change those. So instead of minus each of those, I'm going to say plus a -4, and now it changes to a positive I, which means 1. So the real parts are the 6 and the -4 because they don't have I with them, okay? The imaginary parts are the 3I. Let me grab a different color. The imaginary parts are the 3I, so that's the 3, and then the 1I, so just think of that as a 1. Okay, so that's the imaginary. So the answer is just 6 plus -4, which is 2, plus 3 plus 1, which is 4I. Now, deep down, I think that actually makes it seem a little bit harder than it needs to be. So when we do this one, I'm just going to show you kind of what goes through my mind, and that is, instead of doing this middle part, I just put the like terms together. So since it's addition, you're just saying 2 plus 7, because they're constants, or they're the real part. 2 plus 7 is 9. And then you're just going to add the imaginaries. 5, since that has an I, with a -2, since that has an I, 5 plus -2 is a positive 3. And since they had I's, we put I with it. So it's just like terms. It's just like you added your constants, you added your X's, you add your Y's. In this case, now you just add your I's up and add constants, or in this case, we would call them real because they don't have the I. So that's how I think of it. I think of it as just add them up. Change it to adding opposites if there's subtraction, and then just add them up. But it's because we're putting the real parts together and we're putting the imaginary parts together. Okay? Multiplication has some similarities. It's actually going to take us back to like polynomials like we did before. So let's look at the next page. Okay? So you do want to kind of relate it to what we already know about polynomials. This is why we've done polynomials, okay? And that is, we have a binomial times a binomial. So the way we multiplied binomials was we went off to our box and we multiplied them, okay? That doesn't change. So this says using FOIL. I use the box, okay? So you can multiply however you want. But that's 2 and I, and then this is -5 and 2I. So just use your box to multiply. Let me go ahead and use a different color. So that's -10. This is -5I. This is 4I. 4I, and this is 2I times I is I squared. Okay? So far we have -10 minus 5I plus 4I plus 2I squared. Okay? And then the directions right here say simplify and use I squared is equal to -1. So by simplifying, that just means take these two and put them together since they're both I. So we could have put them together right here and said, okay, that's -10, -5I plus a 4I is a -1I. Just add them up. -5 and +4 is a -1. Okay? But then it also says to use I squared as -1. Well, wherever you see I squared, remember we did that on the other notes, or I think we did it above. No, I guess it was on the other side. Okay? That I squared, remember, means 2 times -1. I squared, replace it with a -1. And all that ever does, every single time, this I squared, that just means it changes this to the opposite. So if I'm saying +2, this is about to change to -2. Okay, so if it said -5, that I squared changes it to +5. A lot of times, last year when I worked with it with my students, we would just do it right here. We would say, oh, well, since I see an I squared, I know I squared is the opposite, so I'm just going to make that -2. And then we would just put those two together, and we would put those two together. So down here, that really means -10 minus I. Again, that changes it to -2. And then we can put -10 and -2 together, because they're real, they're constants, so that's -12 and then minus I. I actually think that makes it seem a little bit harder than it needs to. I do everything really from the box. I put my I's together here, and then that I squared, again, since it's a -1, it changes this sign, so it's a lot easier just to put them together as you see them in the box, okay? So whenever we're dealing with I and we're multiplying with I, we never worry about having an I squared. There's never a squared I in the problem, because I squared means a number, so we just use that number. We use that -1, okay? So now let's divide. It's the last thing before we just kind of practice all of them together. All right, and just like the roots that we had, okay, just like the roots that we had, since I actually represents a negative root, it's a square root of a negative something, you can't have I in the denominator either. So just like we had to use conjugates to rationalize the denominator with roots or radicals on the front side of your notes, this is the same idea. It's a little bit nicer, I think, than dealing with the radicals, but it's for the same reason. Okay, so for example, okay, we have this. We cannot have an I in the denominator. That I stands for a square root, so we've got to get rid of it. Okay, so the way we get rid of it is we use its conjugate. Multiply the numerator and the denominator by something, which is the complex conjugate. So remember, the conjugate just means the exact same thing, but I change its sign. So since this denominator is 2 plus I, the conjugate is 2 minus I. Okay? Whatever we do on bottom, we also have to do on top. Okay? The only reason this takes some time is because we are foiling or using our box to do a ton of this stuff. So this says foil. I use box. Okay? So what we're doing is we're saying this times this, and we're saying this times this. So I'm going to go off and do the box for each of these. So that's 6 plus 4I. And that's 2 minus I. Okay, so that's 12, 8I, -6I, and -4I squared. And then again, I actually thought it was a little bit trickier to see the way that the notes did it. But I just say, oh, this is an I squared. That just changes the sign. So since it changes the sign, instead of -4, this I squared changes this whole box to just a +4. So that I squared just changes that sign. If it's a minus here, it becomes a plus. If it's a plus here, it becomes a minus. So I'm going to use this when I combine. instead of the other. So the numerator is just these two added, so 12 plus 4 is 16, plus negative 6 and positive 8 is a positive 2. So the numerator is that, okay? The denominator we also need to box or FOIL, and we get 2 and I, 2 and minus I. So when I multiply, I get 4, 2I, negative 2I, and negative I squared. Once again, this changes the sign. We'll think of that as a 1. So if this is a negative 1 and that changes its sign, that's going to change this to a plus 1 instead. So whatever you get in here, the I squared changes it. So now I just combine. I say 4 plus 1 is a 5. And then negative 2I and positive 2I, they cancel out, which is exactly what we want. Because remember, the whole point was to get rid of this I. And so now we don't have an I. Now we just have a 5. Okay? Oh, and I actually did all of that. I kind of skipped all the way through. So this is actually the answer. That's the answer. It says to write it in standard form. That's the answer, okay? You could see it like this. You could just separate them. Okay, but they're both over 5, so you could separate them so they're both over 5, or you could write it as one big fraction altogether, the whole thing divided by 5. That means the same thing, okay? So you could see it either way. Multiple choice, you could see it either way. So I like to write it this way, but sometimes it's easier to see this way in case we have to reduce or anything like that, okay? So what we're going to do is we're just going to practice the adding, the subtracting, the multiplying, and the dividing with I, okay?